Alright, first question, we want to find the right Riemann sum with 4 intervals from 0 to 2. So if you start with 0 and you end at 2, and 4 subintervals, that would be 0.5, 1, 1.5. Because then you've got 1, 2, 3, 4 intervals. Now I need to know what the actual values are, right? If this is f, we need to find what, or sorry, x, this is f of x. So plug in 0, that's the square root of 1, which is 1. Plug in 0.5, that's the square root of 1.5. I'm not going to put it in the decimal form because I want to actually keep the answer more accurate. This will be root 2, this will be root 2.5, and then lastly root 3. I'm using a right Riemann sum, so for this rectangle I'll use the right value. So it'll be square root of 1.5 times 0.5, plus this one I'll use root 2. Root 2.5, and last one we'll use root 3. And then type it in your calculator just like this, not the rounded version like the decimal. And when you get this, when you type in, you get, ooh, that's a 6, 2.976, and that's our approximation for a right Riemann sum. Number 2, we're going to use a left Riemann sum with 4 subintervals, so 1, 2, 3, 4. Left, I'm going to use the 5 with this one, so 5 times 2, 7 with this 2, 8 with this 3, and 6 with this 3. And add it up, and this approximation is 66. And the reason I'm doing the approximations is because I'm not actually finding this, right? This right here is an approximation of the interval. It's not exactly 66. 3, so we are looking for a left Riemann sum, 0 to 4, 4 intervals, so 0 to 1. 4 intervals would be 0.25, 0.5, and 0.75. Plug in 0 plus 2, that'd be 2. This is, when you plug in the square root of 0.25, it's 0.5 plus 2 is 2.5. And then the other ones aren't nice, so you just have to do 0.5 plus 2 and square root of 0.75 plus 2. And we're using a left Riemann sum, so it's going to be 2 times this interval, 2.5 times that interval, and here we'll just put it all in. We had to put parentheses around this in your calculator so that when you multiply this by the base of 0.25, it all gets multiplied. Plus, last one is parentheses 0.75 plus 2 times base of 0.25. And this one, we plug in, you get 2.518. Again, an approximation. Number 4, we are approximating the whatever area. I'm only going from 0 to 6, so be really careful. There were questions on the test that I got wrong because I didn't pay attention to something like that. So from 0 to 6, and we're doing it in 3 equal subintervals, so we're going 0 to 2, 2 to 4, and 4 to 6. So I want 3 subintervals. This one we're going to use a height of 0 and a height of 4, so 1/2 0 plus 4 times base of 2, plus 1/2 height of 4, height of 6, base of 2 still, plus 1/2 height of 6, and ending with a height of 2 times 2. And then now you just type in your calculator, and this approximation is 22. That is not going to be the exact area. This one you actually could find the exact area, but we used 3 trapezoids to get the approximation, so it's an approximation. This is just a typo. Right Riemann sum with 6 intervals to approximate 0 to 15. So I'm going to start at 0, go to 15 with 6 intervals. 1, 2, 3, 4, 5, 6. A right Riemann sum means I start with 12 times 3, plus 15 times 3, plus 18 times 2, plus 25 times 3, plus 36 times 1, plus 40 times 3. So add those all up together, and you get this approximation is 348 people. And I know it's people because I'm multiplying people per day times days. is this value greater than or less than the actual integral? So it says that this is strictly increasing, so I'm going to draw something that is increasing. I don't know if it's concave up or concave down, but I know it's increasing. If I have I just did a right Riemann sum, so a right Riemann sum will always be an over approximation for something increasing. So because I'm going to make a note, this is an over approximation. So because this is an over approximation, that means this value is more or greater than the actual value. So this is greater than the integral of 0 to 15 r of t dt because r of t is increasing. Now same, but I'm doing a left Riemann sum, so it's going to be 10 times 3 plus 12 times 3 plus 15 times 2 plus 18 times 3 plus 25 times 1 plus 36 times 3. And put that one in your calculator, you get roughly 283 people. Here, this one still increasing, and I did a left Riemann sum. A left Riemann sum will always be an under approximation for something increasing. So because this is an under approximation, this is going to be less than this value. And your reason is because r of t is increasing. If it was decreasing, the right Riemann sum would be an under and the left would be an over. Trapezoidal sum, so 1/2, I'm still doing 6 intervals, so I have to average each of these. 12 plus 10 times base of 3, 1/2, 12 plus 15 base of 3, 1/2, 15 plus 18 base of 2, plus 1/2, 18 plus 25 base of 3, plus 1/2, 25 plus 36 base of 1, plus 1/2, 36 plus 40 base of 3. Put it in your calculator. In this approximation, we get 315.5 people. Now, if you're like, you can't have half a person, that's okay. I'm not saying 315.5 people. I'm saying this approximation gave me this. It's an approximation, so it's not actually accurate. Now, using correct units, we want to explain what the meaning of the integral is. Not what these are, right? These are actually approximations. What this, if I were able to find it, what this would mean. I'm not asking for a number, right? I already found the approximations. You don't know how to do this yet. So what does this mean in the context? So think about r of t was the number of people that were exposed to a certain illness, and that's the number of people per day that were exposed. Time is the number of days, and the rate that people are exposed is strictly increasing. So if I multiply r of t times t, you're multiplying the rate that people were exposed times the number of days. And that gives me the rate of people per day, right? The days cancel out, you're left with the people. Specifically, that is the people over this entire period of time that were exposed to this illness. So this is the total number of people that were exposed to the illness. And we need to mention something about the time. You can either say over the 15 days. I like to say from day 0 to day 15. Or you can say t equals 0 day to t equals 15 days. It's okay if you do over the 15 days, but I prefer like the very concrete from 0 day to the 15th day. Right, area of this, so 1 and 1 centered at the origin, this function is y equals x squared. So I'm finding the area from, this is -1 to 1, -1 to 1 of x squared dx. And that's my answer, part D. If you looked 0 to 1, because some of you might have thought about A, 0 to 1 is not the whole thing. You would need a 2 right here, right? Double that area and then that gives you the area, but this is not enough. You need twice that, or -1 to 1. Here, so this is like x squared, but see how it got shifted over 1? So that's x minus 1 squared. So it got shifted over 1 to the right. And then I'd like to go 0 to 2, because that's what I have, from 0 all the way to 2. That's not an option, so think about, we know these two areas are going to be the same because it is an even function. So, well, even about this axis. So then it's going to be the same as just 0 to 1, but 2 of them. So that is C. Right. A student wants to find the integral. We use a right sum, a left sum, and a trapezoid to approximate it, and we want to rank each approximation's value in the actual integral from greatest to least. So I know that the derivative is negative, so f prime negative means that it's decreasing. F double prime is positive, that means concave up. So concave up looks like this, and decreasing looks like this. So my graph looks something in this shape. If I were to do a right Riemann sum, a right Riemann sum would look like this. See how a right Riemann sum would be an under approximation? So I'm going to make a note, right is going to be under. A left Riemann sum is going to be an over approximation. And lastly, a trapezoid from here to here. See how a trapezoid would over approximate this area? Over. So it should be pretty obvious that somewhere between over and under is the real value. So somewhere in here is the actual integral, right, of x, whatever, dx. That does not look like anything. Anyway, somewhere between over and under is this. Now the tricky part is like which of these is more over. So trapezoid will always be a little bit more accurate, so the left will be the more over. So it should go left, trapezoid, then the actual integral, a to b f of x dx, and then right will be the smallest because it under approximates the real value. Number 2, we are evaluating negative 3 to 2 of the absolute value of x plus 1. This is not the absolute value of some function f, right? This is the absolute value of x plus 1. That is the integral of the graph x plus 1, absolute value x plus 1. Absolute value looks like this. Absolute value of x plus 1 is shifted 1 to the left, so it looks like this. Something close to that. So this is negative 1. I want to go from negative 3 to 1 to over here. So this base is a base of 2 for this triangle. Because it has a slope of 1, that's a height of 2. So 2 times 2 divided by 2 because it's a triangle. Plus negative 1 to 2, that's a base of 3. It's going to go up to 3. So 3 over 2. So now you just add your two triangles and you get 6.5. Okay, odd is something that is symmetric over the origin, so it could look something like this. If you know 0 to 5, let's say this is 5, 0 to 5, this area is 3, then negative 5 to 5, these two are going to completely cancel out because that will be negative 3, and so the total would be 0. If I know something is even, like this, symmetric over the y-axis, and 0 to 5, this area is 3, then from negative 5 to 5, this would also be 3, so the total would be 6, doubled. Okay, here we're actually calculating the area, these integrals, negative 4 to negative 1, so that's this right here. Two ways to do it, you can do trapezoid and triangle, or you can do this triangle and then triangle, rectangle, doesn't really matter. I'll show both ways, I guess. This is base of 2, height of 1. So that'd be 2 times 1 plus this triangle is base of 2, height of 2, 2 times 2 over 2, plus this triangle has a base of 1, height of 3, so 3 times 1 over 2. 2 plus 2 is 4, plus 1/2 is 5.5. 1.5. You also could have just done the trapezoid, so the trapezoid would be 1/2 height of 1 plus 3 times 2. Plus this one, which is base times height, 1 times 3 over 2. This cancels out, you still get 4 plus the 1.5, which is 5.5. I'm going now from negative 1 to positive 3. So I've got this, this is a circle, it has a radius of just 1, so pi r squared is the area of a circle. In this case, I have half a circle, so divide by 2. So this is pi 1 squared divided by 2, which is just half pi. So I've got half pi, and it's negative, so I'm going to put a negative there, plus, and then this is a triangle, base of 2, height of -1, 2 times -1 divided by 2 is just -1. And those two are both negative because they are below the x-axis. They are like negative areas. From 1 to -4. So 1 to -4 is going backwards. So I'm going to say that's just negative from -4 to 1. So now we actually need to find -4 to 1. -4 to -1, this area right here is 5.5 plus, you've got this -1/2 pi. So this is the area from -4 to 1. I don't want that, right? I want 1 to -4, so that's the flip. So that's going to become -5.5 plus 1/2 pi. Right? If I had gotten this was -2, you'd be like, oh, now it's +2. You just flip the sign. I have 2, and I flipped the sign of each because I flipped the order. Okay. Here, I'm going to break this up into -4 to 1 of absolute value plus -4 to 1 of 3 dx. Absolute value from -4 to 1. -4 to 1, absolute value would put both of these up like this. So then your area would be 5.5 plus 1/2. So this right here is 5.5 plus 1/2 pi. And then anytime you do area of a constant, so if this is my graph of 3, from, I guess we'll go here, -4 to 1, that's a base of 5, and it makes a rectangle with a height of 3, so that would just be 15. Plus 15, 5.5 plus 15 is 20.5, and then you still have the plus half pi. And totally new question. -3 to 5 is 4, 0 to 5 is -2, and I want 0 to -3. So this is like your total, right, all the way from -3 to 5. I know 0 to 5 and the total. So let's set up, I want to add up to -3 to 5. So right now I've got 0 to 5. I would need to go from -3 to 0. So -3 to 0. -3 to 0 plus 0 to 5, yep, that adds up to just -3 to 5. -3 to 5, or sorry, -3 to 0, I don't know, plus 0 to 5 is -2, equals the total, which is 4. So then the integral from -3 to 0 of f of x, add that over, is just 6. Now, that's not what I asked for. I asked from 0 to -3, see how that's the flip, and I also have a 2, so this is going to be 2 times -6, which is -12. So step 1 is I had to find this right here, and then I had to flip it and multiply it by 2. So 6, flip the sign, times 2. Okay, -2 to 1. So it looks like I'm going to have to break these up. So -2 to 1, I have -2 to 4, and then I've got 1 to 4. So see how, if I want to go all the way from -2 to 4, I'd have to go, right now I have 1 to 4, so I'd have to add in -2 to 1. To see how -2 to 1 match to 4, that's the same as -2 to 4. So this is the one I'm looking for, so question mark plus 1 to 4 is -2 equals 1. Add this over, your question mark is 3 then. Now I want 1 to -2. See how that's the exact same as this but flipped? So then your answer is just opposite sign. From 4 to 1, that's just the flip. So that's going to be -1 to 4 g of x dx. 1 to 4 is -2. So -2 is +2. 4 to 1. So this is going to be 5 times 1 to 4, but flipped, so we put the negative g of x, so that's -5 times the -2, which is +10. Here, the x is getting like shifted, so it's being shifted left to, so I need to plug these in right here, and then I'm going to shift it with the thing, right, dx, and then when I add 2, that becomes 0, and when I add 2, this is -2, is that positive or negative? Oh, sorry, that's a positive, so when you add 2, it's 4. So this is just the same as -2 to 4 of just g of x, not shifted. And -2 to 4 of g of x is just 1. in 4 to 4, anytime it doesn't matter what the function is, when you don't actually go over, you can't have an area. Alright, here we have velocity as a function of time. So if I want to go from 1 to 5, so that's just here to 5, don't go to 6, like I am tempted to do. So just 1 to 5, I want to find the total distance. Well, distance is just going to be velocity times time, so you're multiplying the y times the x, so that's just area. So trapezoid, another trapezoid, another trapezoid. So I've got 1/2, this is 30 and 40, times base of 1, plus 1/2, this is 40 and 10, base of 2. This one is 10, and this one is 25, base of just 1. And you put it in your calculator, and I got 77.5. And your unit, when you multiply miles per hour times the hours, is going to give you miles. Alright, some more areas. So here I'm going from -5 to -3, so -5 to -3, except for I'm not finding it at f, I'm finding it at the absolute value, so this would actually get flipped up right here. So I'd be finding these two areas. This one was base of 1, man, I drew all over it. I think it's still base of 1. Base of 1, height of -2 divided by 2, 1, except for that's positive 2. Plus, this one's still a base of 1, height of 2 divided by 2. So that is 1 plus 1, which is 2. If I didn't have the absolute value, it would be -1 and 1. But because I had absolute value of x, the function got flipped up. -4 to -1. So -4 is here, going to -1. Random area, but that's okay. So I already have this one. This one is positive 1. And then this is just a trapezoid, so it's going to be 1/2 height of 2 plus, ooh, what's that height? That's 1. That's not 1. Did I mean to do this? Oh, man. I meant to do that. Oh, no, I didn't. Okay, cool. I jumped ahead of myself. This is not f of x. This is f of x plus 1. So this is the same as if I just did f of x, but with 0 and -3. Oh, that makes it so much easier. Also, that was wrong. Sorry, guys. So see how your x got shifted to the left? So you just need to shift with it. So this would be -3 to 0. And -3 to 0 is just 1, 2, 3. Just this trapezoid right here. So it's going to be 1/2 height of 2 and then height of 1 times base of 3. So 3 times 3 over 2 is 9/2 or 4.5. Here we are doing the integral from -3 to 0 of f of x plus the integral of -3 to 0 of 1 dx. -3 to 0 we just found, right? That is going to be 4.5 plus -3 to 0 is a base of 3, and it would be -3, 0, height of 1, so that's just a rectangle. So base of 3 times 1 would be plus 3, so that's just 7.5. And lastly, our limit process. So this is my function right here. This is my interval. So this is like your a to b, so like 3 to 4, something like this. So my interval is always going to be b minus a over n, or sorry, my delta x is always going to be the b minus a over n. 4 minus 3 is 1, so it's 1 over n. So we can cross off b and d, because that would be if your delta x was like a difference of 2. So I've got 1 over n. We're always going to be plugging in your a plus I or k, doesn't matter, delta x. So a here was 3, so you're going to be plugging in 3 plus k, delta x we said was 1 over n. And this is what you're plugging in for x, so I'm plugging this into the x to the 4th. So I should have 3 plus k 1 over n all to the 4th. So 3 plus k over n all to the 4th times my dx, 1 over n, and it's the limit and the summation, so a. So here I want to set up my limit to find the area from here to here. So my b minus a over n is going to be 4 minus 0 over n, so 4 over n. I'm going to start with my limit n approaching infinity. Sum, you can use k or I use k. So I start at 1 and I go to n number of rectangles, and I'm going to be plugging into f of a plus k delta x. A is going to be 0, so that just goes away. So I'm plugging in k delta x, in this case delta x is 4 over n, so I'm plugging that into my x. So I've got 4k over n cubed plus 4, like this, and then you got to multiply by dx, which is 4 over n. Here, my delta x is 2 minus 0 over n, so 2 over n. My a plus k delta x is going to be 0 plus k 2 over n. This is what I'm plugging into my x. So this should be a limit as n approaches infinity, sum k starting at 1 and going to n of, I'm plugging into my function, so this would be 2k over n squared plus 1, and then all of that needs multiplied by delta x, which is 2 over n. That's your answer. Lastly, I have the limit and I'm finding the function, so you should notice that your delta x is I over n. I is like the same as k. So then you've got, I think I meant that to be a 1. That's a typo, that's supposed to be a 1. So then your change in x is 1. So, okay, all of those have a difference of 1. That's not that helpful. You should notice that it's plugging into the square root of x function. And you should notice that you don't have an a value, because it's not like I started with 1 plus I over n, right? So I started with 0 plus that, which is why it's this. So I need to start at 0 and go to 1. And then I didn't plug into 1 over root x, right? I just plugged into root x, so it's a.